We have another example on the board. This is RLC circuit, but please notice that we have DC power supply. When we have DC power supply, we assume that the impedance of the inductor is equal 0 ohms and impedance of the capacitor is very large, we say infinity, so very large resistance. Okay, so inductor is going to behave like a short circuit and capacitor is going to simply open the circuit. So if I have capacitor in the branch like this one, right? So it means that current doesn't flow into that branch, so I'm going to cross this out. And basically, let's see what we have got. We have resistor R2, we have resistor R3, we have resistor R4, we have DC power supply, we have also resistor R5. Now, when students look at circuit like this, many of them get confused because they're still thinking which resistor is in series with which and which resistor is in parallel with which. So we're supposed to redraw the circuit in order to make this circuit a little bit simpler. In order to do so, you can label these 2 points, point A and point B. Okay? And we get used to that the power supply is at the left side. Okay, so I'm going to draw the DC power supply at the left side. Okay, so the positive terminal, right, of my DC power supply is connected to resistor R4. That's why I'm going to connect DC positive terminal to R4, right? R4 is connected to point A. This is my point A. Point A is connected to resistor R3. That's why I'm going to draw over here R3. R3 is connected with R2. With R2. And R2 is connected to point B. So this is my point B. And also the negative terminal of my voltage source is connected to point B. Okay, so I'm finished with this branch. Next, please notice that point A is connected to resistor R5, right? And the other terminal of R5 is connected to point B. So now, let's take a look at this circuit. This circuit looks much simpler than this one. We can clearly see that these 2 resistors are in series, okay? And this resistor is in parallel with these 2. So what we're supposed to do, we're supposed to find the total resistance of these 2 resistors first, because we have to find Z total first. So I have R23 is equal R2 plus R3, where R2 is equal 7 kilo ohms plus R3 equals 6 kilo ohms. So this is equal 13 kilo ohms. So we found the total resistance of these 2 resistors. Now we can redraw the circuit, and your circuit is going to look like this. I have DC power supply, and I have R4 resistance R23 and resistor R5. Now we can see very clear that these two resistors are in parallel. Because I have two resistors, I can use the formula which is called product of the sum. So I have R2, 3, 5 is equal R2, 3 times R5 over R2, 3 plus R5, where R2, 3 is equal 13 kiloohms times R5, which is equal 8.6 kiloohms over 13 kiloohms plus 8.6 kiloohms. This is equal 5.17 kiloohms. Okay, so this is the resistance R235. Now I can redraw the circuit, and I'm going to have power supply, resistor R4 and resistor R235. In order to find the total resistance, I supposed to add these two resistances because they are in series. So I have R total is equal R4 plus R235, which is equal R4 7.2 kiloohms plus R235, which is equal 5.17 kiloohms, which is equal 12.37 kiloohms. Okay, so this is the total resistance of the circuit. Next, we're supposed to find I total. In order to find I total, we are going to use Ohm's law. I total is equal voltage source over R total. Okay, don't forget that anytime we talk about R total in this case, this is equivalent to Z total. Okay, so we can say this is voltage source over Z total also. So voltage source is equal 25 volts over Z total, which is equal 12.37 kiloohms. And this is equal 2.02 milliamps. This is my I total. We're supposed to find the voltage across resistor R4. Okay, so if you want to find the voltage across this resistor, you're supposed to realize that the current I total will go through resistor R4. So the current I total is also equal to current I R4, because as I said, I total goes through resistor R4. So in order to find voltage, I'm supposed to use Ohm's law. VR4 is equal I R4 times R4, where IR4 is equal 2.02 milliamps times R4, which is equal 7.2 kiloohms. This is equal 14.54 volts. So this is the voltage across resistor R4. Next, we're supposed to find the current which goes through resistor R1. R1 is the part of the branch where there is no current. Why? Because capacitor behaves like an open switch. Okay, so if there is no current, it means that the IR1 is equal 0 amps. So there is no current in this branch, there is no current in this resistor. Next, we're supposed to find voltage across resistor R5. Okay, we're supposed to find this voltage. In order to find this voltage, I'm going to use KVL, okay, because you're supposed to realize that voltage across this resistor, okay, voltage across this resistor is the voltage which is going to appear across resistor R5 and across resistor R23, okay. I'm not looking for voltage across resistor R23, but R5 is going to have the same voltage. That's why I can simply write that VR5 is equal voltage source minus VR4. Okay, so VS is equal 25 volts minus VR4, which is equal 14.54 volts. This is equal 10.46 volts. So this is the voltage across resistor R5. Next, we're supposed to find voltage across inductor. So what we're supposed to do, you're supposed to realize that the impedance, right, if it's not specified, of the inductor is equal 0 ohms. So the formula for voltage is equal current times impedance, because, let's put it this way, IL5 times the impedance. But we said that ZL is equal 0. 0 times anything gives me 0 volts. Okay? So we found Z total, I total, VR4, IR1, VR5, VL5, so we can say that the problem is solved.